Ladies and gentlemen, welcome to yet another lesson of circle geometry with me, of course, Mr. M. Today we'll be tackling, or rather on this lesson, we'll be tackling the seventh theorem of the circle geometry or Euclidean geometry. And let's get right into it. With this theorem 7, it states that tangents that are drawn to the circle from the same point outside the circle are equal in length. So basically what it says is that if I'm having tangents that are drawn from the same point outside the circle, they should be equal in length. So I'm going to just show it, and then now the keywords length. Length is actually how long something is, and then we are having outside the circle, meaning outside the circle. So I'm just putting it on the keywords because I'm trying to emphasize that it should be outside a circle, because in an exam, especially when you're dealing with writers, I need you to keep this in mind. When you're dealing with writers, they might give you something that is inside a circle but seems to be outside a circle. Do you get the vibes? So just don't fall for it, just work with it. And then the terminology that was used was what? Was tangent. And we know that a tangent is a line that touches a circle or the circumference of a circle at one distinct point. Now this theorem, ladies and gentlemen, it forms an ice cream. So this ice cream theorem that you're going to remember it with, obviously it's an ice cream theorem. This ice cream theorem says that this is the point, let us name it point T, and then these are the tangents, and we are saying that these tangents are equal in length. So they will always be what? Equal in length. So just put that in mind to say this tangent will always be equal in length. And then your reasoning, ladies and gentlemen, your reasoning ladies and gentlemen, will be what? Will be tangents drawn from the same point. Drawn from the same point. The same point. So we know that the tangents that are drawn from the same point outside the circle, which is point T, they should be equal in length. So let us say here we're having A and then here we're having B. So basically what we're saying is that the TA should equal to the BT or TB in essence. So this is just that. And then we say the reason is tangents drawn from the same what? From the same point. And we know that applies when this point here is outside what? Outside the circle. Hope that makes sense, ladies and gentlemen. And with that being said, on the next lesson, we'll be tackling theorem 8, which states that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. So the keywords that I need you to go home with and put in mind, it's alternate and what? And segment. We've talked about the point of contact, you can revisit that, and also the tangent and the chord will be the terminology that will be used. So now, ladies and gentlemen, thank you for watching. Please subscribe for more lesson videos. Bye, donkey.